Hi, in this video, they are given you two vectors and they ask you to find the value of lambda. Okay, and if the vector A and vector B are parallel vectors, right? So there are two alternative way of finding the parallel vectors, right? So the first one, of course, you just learned about vector product. So I'm going to teach you about the way of using vector product. Alright, so if you have understand this through the first video, I have said that if the vector A parallel to vector B, then A cross B, the vector A cross with vector B, you are getting a zero vector. It's not zero, it's a zero vector. Or the meaning here, zero vector will be 0i, 0j, 0k. They are not moving in any direction. All right, so they are static. So let's say if A parallel to B, then A cross B will produce a zero vector. All right, this definition I just use the result from the first video that I already explained. Why I getting this result, you should refer to the first video. So now I will using this result. So if A and B are parallel vector, A cross B will produce zero vector. So what I'm going to do now is I'm doing cross product between vector A and vector B. Alright, I'm going to do cross product between vector A and vector B. So means that I use the definition of the determinant of 3 by 3 matrix. Alright, or I said the expansion of determinant, right? Expansion of determinant, or I'm using the definition of 3 by 3 determinant of a 3 by 3 matrix. So negative 2 A, negative 1 2, 4 2 lambda, right? So I just doing cross product A, right? A cross B 4 2 lambda, right? So I just using the normal way of finding the determinant of matrix, which will be I minus with J, right? Minus with J plus with the minor of K, right? So what is the minor of this I here? So delete the row and the column. We have negative 1 2 2 lambda, right? Negative 1 2 lambda, right? So, and for this J, the minor for J, delete the row and the column. We have negative 2 2, negative 2 2, 4 lambda, right? 4 lambda. And for K, right? K, so it will be negative 2 times 2, negative 2, negative 1, sorry, the minor for K is negative 2, negative 1, 4 and 2. Right, 4 and 2. So now I'm going to evaluate one by one. Negative lambda minus with 2 to 4. So minus with negative 2 lambda, right? Negative 2 lambda minus with 4 to 8 J, and plus with negative 2 times 2, negative 4, minus with 4 times negative 1, we have negative 4, right? And it produced, so you try to calculate and simplify again. So as I get, I will getting A cross B. The final form will be negative lambda, negative 4i, and minus with negative 2 lambda, negative 8j, plus with negative 4 plus 4, we have 0k, right? We have 0k. So why are we finding A cross B? Because based on this definition, the question said given these two vectors, find lambda, they're asking you to find the value of lambda so that these two are parallel. So if these two are parallel, the result will be A cross B will be a zero vector. So it means that this whole thing here will actually equals to zero vector. 0i, 0j plus with 0k, right? As k is already have a coefficient of 0. So let's look at vector I, right? So I will compare negative lambda, negative 4. The value here have to be 0. And I will getting the value of negative 4, right? It's the same thing also. If you compare the coefficient for the vector j, which is negative 2 lambda minus 8, right? This whole thing have to be equate to 0 as well. So if you multiply the negative inside, so you are getting 2 lambda plus 8, so lambda negative 8 over 2, negative 4. You were still getting negative 4, right? So means that the value of lambda is negative 4 when the two vectors are parallel, right? So this is the way I'm using cross product, right? The knowledge of cross product. Okay, I'm going to show you another way. For this question A, I will show you both ways, all right? Now I show you the cross product, and the other way will be using a concept of parallel vector, the definition of parallel vector. All right, there will be another alternative methods. We say that vector A is parallel to vector B, right? Just now we're using the knowledge of cross product, and we also can using the knowledge of your previous your prior knowledge, which is from your learning during your secondary school, whereas A equals to K times B. So if these two vectors are parallel, they can be related by a constant, right? By a multiple K, so which K cannot be 0. So I can just compare, right? I can say negative 2, vector negative 2, negative 1 and 2 is K times, alright? K times the vector 4, 2 and lambda, right? So this is a lot easier compared to vector product. So what I'm going to do is I'm going to write negative 2 equals to 4k, because I can only write this if these two are actually parallel, right? So then giving me the value of k to be negative half, right? The same thing also if you compare the y component. So negative 1 is the same with 2k, and k you are still getting negative half, alright? Means that I know that A is negative half of vector B. So now I can calculate lambda by using the z component, which is equals to k lambda. And I know that the value of k is negative 2, right? Lambda. So finally I can get lambda to be negative 2 times 2, I'm getting negative 4, right? This is a lot faster compared to the vector product, but you must have enough knowledge for vectors, as you must know both, alright? One is this methods and the other one will be using the cross product. Alright, now let's discuss, in this same video we discuss about perpendicular vector. Alright, okay, let's discuss about what if the two vectors are perpendicular and how to find the value of lambda. So of course I'm going to show you another two alternative method, right? Of course you just learn about vector product, right? You are just learning about vector product. So vector product said that if a vector A is perpendicular to vector B, then the magnitude of A cross B will be the same as the multiplication of magnitude of A with magnitude of B, right? So as long as these two are the same, the value as the product of magnitude, respective magnitude of A and B, if after multiply you get the same value, that means that these two vectors are actually perpendicular, right? Based on the definition. So, okay, I need all the information here as I need to find the magnitude of A cross B, right? At the first, when I calculate, when I'm using vector product to calculate the value of lambda when they are parallel for part A. Okay, now this is part B, right? So now I have already found my A cross B, right? A cross B, which is the negative lambda minus 4i minus with negative 2 lambda minus 8j, right? So I can find the magnitude of A cross B, right? Magnitude of A cross B, which will be square root of negative lambda negative 4 to the power of 2 plus with negative 2 lambda minus 8 to the power of 2, right? The way with A square, B square, C square, right? C square. So this is the way we find the magnitude of A cross B, right? So from here I can expand this whole thing, or I can just rewrite this to be negative. I can factor out the negative 1, and we have lambda minus 4 to the power of 2, right? And this is also power of 2, right? So because I factorize the negative 1, So negative 1 also power of 2, lambda minus 4, or sorry, lambda plus 4, right? Because if you multiply negative, you get it negative lambda, negative, positive, negative 4, right? So square is for both. So now it's the same thing for this. If you multiply this inside, if you look at negative 2 lambda, negative 8, it's actually 2 lambda plus with 8. I can rewrite this with 2 lambda plus 4, isn't it? Right? I can just write this one, expand first, and 2 I factor out, lambda plus 4. So it means that this whole thing is power of 2, right? It's power of 2. It's power of 2. It shall show that this whole thing is power of 2. So it's 2 power of 2 is 4. Lambda plus 4, right? 2 power of 2 is 4. Lambda plus 4 to the power of 2. So I have here to be 4 lambda plus 4 to the power of 2, right? And square root this whole thing. So this you are getting 1, right? Negative 1 square, you are getting 1. 1 plus with 4, we have 5 lambda plus 4 to the power of 2 square root, right? So this is the magnitude for A cross B. So leave this alone first. So now we follow by finding the magnitude of A, right? The magnitude of A. So the magnitude of A will be the same as the square, right? The square root of the negative 2 square, the x component, the negative 1 square, plus with 2 square, right? So we were getting 4 plus 4, 2 square plus 1 square. So 4 plus 4 plus the square root of 9, which give you 3, right? Which give you 3. And also at the same time, we find the magnitude of B, right? Because we need to equate these two, right? Because they are perpendicular. So magnitude of B will be 4 square plus with 2 square plus with lambda square, right? Square root lambda square. So we were getting the value of 16 plus 4, right? 4 square is 16. 16 plus 4, we have 20. So 20 plus lambda square. So now we have magnitude of A, right? Then we have magnitude of B. So we can compare this to the multiplication of these two, right? Okay, let's calculate. Alright, okay. Just now we have find our A cross B, the magnitude of A cross magnitude A magnitude B. So as if these two are parallel, two are perpendicular, then we can compare. So we have square root of 5 lambda plus 4 square is the same as the magnitude of A 3 with square root of 20 plus lambda to the power of 2, right? To solving this, we know that this is a square root, so we have to squaring both sides, right? Squaring both sides. So we were getting 5 lambda plus 4 to the power of 2 equals to 3 square will be 9, 20 square root, and square you were getting 20 plus lambda square. So we just expanding. This is quite a very tedious way, right? But it's based on this definition, based on this result. This is important that you must know. So 2, 4, 8 lambda plus with 16 equals to 9 to 180 plus with 9 lambda square. We have to be patient. 5 lambda square, 5, 8, 40. 5 times 16, we have 80, right? So we have 80, and 9 lambda square minus with, I bring this all over going that side. So 9 lambda square minus with 5 lambda square, we have 4 lambda square, right? So now 40 bring over that side, become negative 40 lambda, right? 180 minus with 80, you have positive 100, right? 180 minus 80, you have positive 100. And I'm going to divide this quadratic. If I'm getting a quadratic, divide by 4. So I will minus with 10 lambda plus with 10 lambda. Alright, divide by 4, divide by 4. So divide by 4 for this, you are getting positive 25, right? So if I factorize this, finally, right, with a Oh, long-winded way. So lambda, lambda, 5, 5, 25. So negative 5, negative and negative 10. So we have lambda minus 5 square to be equal 0. So lambda have to be 5 to making this thing equals to 0. So the value of lambda is 5. So means that when A is perpendicular to B, the magnitude of A cross B is the same as magnitude of A multiplied with magnitude of B. So we're using this definition. So of course we follow all the procedure that we're doing, we calculate, we were getting the value of lambda that we need. So, but this is a very long way, right? Except if the question asking to using vector product, right? But if I were not using this because I know there is another knowledge that I learned before, which is a dot product. I can using dot product, right? Let's see that alternative. Alright, the alternative methods, right? So usually when I discuss alternative method, this will be a shorter way of doing, right? But as a student of learning something knowledge, you have to learn everything. Alright. So alternative method is if A is perpendicular to B, and we're using the knowledge of dot product. We know that if two vectors are perpendicular, the dot product of these two vectors, you will produce a 0, right? A scalar, right? 0. So very easy result. So means that they have vector A and B are perpendicular vector. So I just take A dot with B. So vector A, which is negative 2, negative 1, 2, I dot with the B vector. So 4, 2, lambda. So just equate it to 0. A lot simple, right? So we just do dot product negative 8. Negative 2 times 1, negative 8. Negative 1 times 2. Plus, right, positive 2 lambda. So you are getting equals to 0. So 2 lambda will be equals to 10, right? 10. So lambda equals to 5. Wow, it's a lot easy, right? So means that you have to know your knowledge. You have to know what method to use. Except requested by this question, they want you to do cross product. If not, you can use a knowledge from your the properties of vector product and dot product, the mix of the knowledge in solving some certain problem involving perpendicular and parallel. Alright, I think that's all for this video. Hope you enjoy it and understand.